Hey everybody, for today's lesson, for 5F, it's really just factoring practice, because by this point you would have seen various types of factoring. So with the factoring practice, give me a second here, I have split them up into this 1, 2, 3, 4 different types of factoring. Now ideally at this point what I would do is probably mix it all up, and it's up to you to decide what type of factoring you should use. But I don't know if everyone's at that same level yet, so what I decided to do is just split them up into the 4 categories, or the 4 different types of factoring. So there are quite a bit of questions, quite a few questions here. I don't know if you guys would be able to finish all of them, but just attempt as many as you can. Yeah, and submit what you can, and I'll mark accordingly. Okay, anyway, let's see. Comment pencil. Alright, common factoring. So common factoring, once again, is just looking at the 2 terms and seeing what's common. So in this case, both these terms, it looks like I can factor out a 2. I can also factor out, since there's an x, 2 x's there, a single x there, I could factor out 1x, which then leaves me with 4x. 8 divided by 2 is 4, x squared divided by x is x, 10 divided by 2 is 5, and then got 1x there, I factor out that x, and there, we're done. If you're not sure if you're correct, you could do the opposite and multiply it in. 2x times 4x is 8x squared, 2x times 5 is 10x. That's done. Okay, something like that. How can I factor that? Well, what's common in both 12 and 16? 4, and I think that's all I can do. So that just gives me 3y, because 12 divided by 4 is 3, 3y minus 4. Okay? And that's what the first 15 questions are like. Simple factoring. So this is where you know the a value is equal to 1. Okay, so in this case, a value is 1. So I just need 2 numbers that will multiply to give me 7. But at the same time, they must also add to give me 8. And those 2 numbers will be 7 and 1. 7 and 1. So my factored form here would be x plus 7 and x plus 1. Okay, and that's the same for all of them. For all these 8 questions anyway, or 10. Complex factoring. So complex factoring would be when a does not equal to 1. Okay, so in this case, a clearly is not 1, it's a 3. So I need 2 numbers that will multiply to give me whatever 3 times negative 5 is, and that's negative 15. And at the same time, those 2 numbers must add to give me negative 2. Negative 2. So my 2 numbers would be 5 and 3. 5 and 3. However, I notice that's a negative 2. So if I set this as negative 3, would that make sense? Well, 5 plus negative 3 is actually positive 2, which means my 5 should be negative. Okay? Now, what do I do with those 2? Well, since it's complex, I have to split the middle term to negative 5p plus 3p. Okay? And then I can copy the rest down. So if I copy that down, that becomes 3p squared. If I copy that down, that becomes negative 5. And then it's just a matter of factoring by grouping. So if I look at these 2 terms, what's common in both of those? Looks like just a p, really. If I factor out a p, I'm left with what's in here? 3p minus 5. Okay? And over here, can I factor anything out? Nope. So I'm just going to factor out, I guess, a 1. So I'm just left with 3p minus 5. Okay? So now, oh, sorry, maybe I should split this up. Okay. So if I common factor here, what can I take out of that? A 1. So just 3p minus 5. Now, clearly you can see that this and this are the same thing, so this just becomes 3p minus 5, and then what's left over? A p plus 1, p plus 1. Done. Okay? So once you've got it in brackets, you're fully factored. Alright, and the last set, and these are the easier ones, difference of squares and perfect squares. So if I look at this, I see it's a difference of two terms. Okay? 2 terms, and it's a minus in between, so it's difference. So we have 2x, square root of 4 is 2, square root of x squared is x, minus 3, and then 2x plus 3. And then down here, you could use complex factoring and find 2 numbers that will multiply to give you 36, but add to give you 12. Or you can realize that, wait, is this a perfect square? What's the square root of 4? Sorry, what's the square root of this whole thing? And that's 2. What's the square root of 9? Well, that's 3. Okay. Well, what's 2 times 3? That will give you 6. And 6 doubled would be 12, wouldn't it? So if that gives you a 12, then we know this is a perfect square, which means the 2 roots are 2x, so square root of that, 2x plus 3, and 2x plus 3. Or you can write that as 2x plus 3 squared. Okay? If you have any other further questions about this, again, please post under math questions and I'll respond as quickly as I can. Alright, take care.